Okay, here's question 6, 7, and 8. These are inequalities, or at least 6 is an inequality, which means we're going to use a number line to solve this. And the first number that's going to go on that number line, if I just draw a number line here, the first number that's going to go on that number line is anything that makes the denominator 0. So right here I have this denominator x minus 6, and what value for x would make that 0? That would be 6. So x is not going to equal 6, so that's going to be one of my boundary restriction points on my number line. And the other one is then going to be the solution of when this is actually equal. So I'm going to go ahead and solve x over x minus 6, and when is that equal to 3? All right, so to do that I have a proportion here, so I'm going to use my cross products property. Take 3 times x minus 6, set that equal to x times 1. And I'll solve this, and it looks like negative 18 will equal negative 2x, so x is going to be 9. So that's my other boundary point. I have 9 and I have 6. So I'm going to go ahead and put those on the number line here. And remember not to color in 6, because if x is 6, that'll make the denominator 0. So you do not include that, but you can include 9 because it's less than or equal to. So now I'm going to test to see where my solution is going to be. And so let's just test a number in between here. Let's test x equals 7. So if I put 7 in here, that's going to be 7 over 7 minus 6, which is 7 over 1. Is that less than or equal to 3? That is false. So we are going to be false in between here. So then most likely we are going to be true out here and here. So if I put a 0 in there, that is certainly will be true because 0 is less than 3. And if I put a number bigger than 9 in there, say 10, if I put 10 in there, what will I get? 10 over 4, 10 fourths, that is also going to be less than 3. So it is true on each side, and what a lot of people I've found are having trouble is writing this corresponding inequality. So if this is disjointed here, you're going to have to use the word or in your inequality. And so this disjunction would be written as two parts. X is less than 6, or x is going to be greater than or equal to 9. Those values will make that inequality true. Number 7, we have an equation with a bunch of fractions or rational expressions in it. And one way to get rid of all the fractions in an equation is to find a common denominator between all three of them. And so to do that, I'm going to factor what I can here. And this, I can factor a 2 out. And I then notice that I have both of these factors included. So really I only have two factors. I have x plus 4 there, and I have 2. Okay, and so on the right side of the equal sign, it has both of those factors. But on the left side, each one of these expressions needs to have one of those factors multiplied in. So what I'm going to do is I'm going to need to multiply this one here by the blue factor, and I'm going to need to multiply this one here by the red factor. Okay, so that would look like this is going to be multiplied by 2 over 2. And this one here is going to be multiplied by x plus 4 over x plus 4. It's getting a little messy in there. So let's clean this all up so that we can see what's going on. So let me use some brackets. I'll use this color green. So I have this term right here. I have this term here. And I have that term. It's all equal to that. So I basically have 3 rational expressions I'm working with. Okay, so the far left one is going to be 2x over 2 times x plus 4 plus, then this is going to be the product of x times x plus 4, which is going to be x squared plus 4x, over that same denominator, 2 times x plus 4. And all that stuff is going to equal, I didn't have to do anything to this one, so that's going to be 2x over 2 times x plus 4. And so when I have all the denominators that are all matching, I can go ahead and just, all these things are matching. I can just ignore those for a moment and solve the numerators. So I'm going to go ahead and solve the numerators, and I'm going to clean up that equation. So I have 2x plus x squared plus 4x equals 2x. And I see that I have, of course, two sides of the equation. And if I have a 2x on each side, I can subtract those from both sides, so those are gone. So what I'm left with is x squared plus 4x equal to 0, which is good because I want to set my quadratics equal to 0. I can factor out an x here. And I can solve this one by factoring. The two solutions here are going to be 0 or -4, so long as they are not restricted values in any of my domain that would make a denominator 0. So I look at my denominators, and it looks like my restricted value would be -4, so I have to omit that from my solution, as that would actually not work out. So my only solution here is x equals 0. That's the only thing that would make that equation true. Okay, this last question, we have a word problem, and it's a distance, speed, and time problem. So this is what we're going off of, distance equals speed times time. And that also can be rewritten as time is equal to distance over speed. So if a train has traveled 120 miles from Freeport to Chicago and returned the same distance in a total of 5 hours. So this part right here where it says in a total of 5 hours, that's telling me that we're going to be talking about time in this particular problem. And when I see something of a total of time of 5 hours, I like to think that something is going to equal 5. The sum of something is going to equal 5. And that sum is going to be the time that this train traveled from Freeport to Chicago and back. So time, I guess we could say time 2 plus time back has to equal 5 hours. And time is a measure of distance over speed, and in this case we are going the same distance in each case. So this is going to be, I'm going to substitute distance over speed, and one of the speeds, well, I don't really know the speed, but I know that one of the speeds is 20 miles an hour slower than the other. So if I use x for my distance, well, let's see, which one are we going slower? If the train traveled 20 miles per hour slower on the return trip, so this would be an unknown value x for the speed there. And I do know that on the return I went the same distance, but I just went 20 miles an hour slower. So what I really have now after I set up this relationship is a rational equation with, essentially 3 rational expressions involved. And so what I want to do then is have all the denominators be the same and then just drop them out and ignore them. So what I'm going to do is multiply this. So let's see, let's call this the red factor, and this can be the blue factor, and this I have none. So this one needs a blue and a red. This one needs just a red, and the first one, of course, needs a blue. So now they all have blue and red. Okay, so let's go ahead and do that. Voila. I paused it and wrote in all of those factors. So now if we clean this up a bit, notice that all the denominators are the same. And over here on the right side, I had just multiplied these two together. So x squared minus 20x is the product of the red and the blue, x times x minus 20. And so what I'm going to do is clean this up a bit, and then we'll solve for the numerators. So multiplying out all of the numerators, what I have then is all of these cleaned up. So really, I'm not focusing on any denominators here. I'm just cleaned up all of that stuff in orange. And so what I can do then is simplify a few more things, and I'm going to have a quadratic equation that is going to be set equal to 0. So I have 120x and 120x there, which those are going to combine to make 240x. So on this side I'll have essentially 240x minus 2400 equal to 5x squared minus 100x. Now I like to have my leading coefficient positive, and so therefore I'm going to move this 2400 over to the other side, and I'm going to also move this 240x over to the other side as well. So I'm going to rewrite this set equal to 0 with a positive leading coefficient. Okay, so in green I have my equation all cleaned up, and I'm going to factor to solve this if I can, and they're kind of big numbers, but I think it works out. So if I can factor out a 5 out of each term, I notice right away that will give me a 1x squared minus 68x plus 480 equal to 0. And so I can hopefully unfoil this. And so my first terms are going to be x and x. Factors of 480 that have a difference of 68. 60 and 8. Or have a sum of 68 rather. So they're both going to be minus minus because this is a plus right here. So these have to be the same, minus minus. And since it's a minus in the middle, they're both minus, of course. So this is going to then be minus 60 and minus 8. And so those two solutions then would be x equal to 60 or x equal to 8. And so now I have to do some thinking back from the beginning of the problem. And so I had two speeds. One of them was x, and one of them was x minus 20. And so if I put 60 in for x, I will have 60 and 40 as my speeds. If I put 8 in for x, I would have 8 and negative 12. And it is for that reason that I'm going to ignore that 8 as one of my possible solutions because it gives me a negative speed. And I will determine that 60 is the mile per hour of the train there, and 20 miles an hour slower on the way back would be 40 miles per hour. Okay, so that is problems 6, 7, and 8. And in the last video, we will finish this up and do 9. We will do 9 through 14. We'll maybe do 2 more videos, 9 through 14, and then we'll do the last 4. So stay tuned.